It's better if you do that. And also, I think it's a good idea for you to present yourself with us. The only thing I know about you is your name. So.
All right. So let me know when you want to get started.
Now.
Yeah, we can do it now if you want.
Yeah, let's start now then.
Are you broadcasting?
Yeah, I'm broadcasting. So you're okay. You're famous now.
Well, so thanks for having me. I mean, I think people know that Hernan and I go way back. I mean, he used to work for IBM at some point in time. It's a time ago, and we took a lot of graduate classes together, especially around object-oriented computing, and I think you guys have maybe one of the people I know as the best in objects, easily. So you're very lucky. I mean, I can tell you, I learned a lot from him, especially around the time when we were taking classes with, Smalltalk. And certainly I got into Ruby, and a lot of the discussion we've had about objects were spot on. So I think this is great. One thing I will do today is to kind of talk about the work that I'm doing now, which is more related to cloud. However, I told Hernan that I'll try to leave a little bit of time so at the end, maybe we can have a discussion about not necessarily objects, but Google Golang, which is this language that has some objects in it, but not necessarily. But the reason I want to mention is because everything we're doing in the cloud at IBM and in Cloud Foundry is essentially using Golang. So we've got rid of, our use of Ruby, Java, Python to essentially favor Golang. And there's a very good reason for that. And the talk is not going to be about that aspect. Maybe we can have a separate talk about this. But I think it's important for you guys to understand how important this language is becoming.
Great. Yeah. Cool.
And I have a few slides on it to kind of compare, Golang with Ruby. So maybe we can get to that too at some point.
Great.
So for now, let's start with a little bit of what I'm doing at IBM today, because I think it's interesting, because it could be something that you guys would be interested in, even be part of at some point. And it's essentially Cloud Foundry. So I'm going to present so that it's easier. And I'll go fast on this just because I want to get some time to go to the other presentation about Golang, which I think your class might be more interested in. But it's going to set the stage for why those opinions are in a reality. I mean, at least the opinions you're going to see about Golang are based on my work on Cloud Foundry. So what is Cloud Foundry, and somewhat how can you participate? This is what this talk is about, right? A little bit. So I'm going to skip some of the demos and instead give you links to where you can go and try things, and instead, kind of give you a quick idea. So first thing is that Cloud Foundry is this operating system for the cloud, right? And in some ways, it's service framework agnostic, meaning that you can use Java, Ruby, Python. I don't think there's anything for Smalltalk, but pretty much every other language out there, mostly object-oriented language, and the frameworks exist and are supported. And it's also cloud agnostic, so that you can take that same platform and put it on AWS, OpenStack, SoftLayer, and so on. And it's also even container agnostic, so things like Docker and Garden, Warden, Guardian, and so on can all be used. So the way to think of it is, instead of taking your application written in Ruby or Smalltalk or Python and running them on some kind of a VM, you running them in containers. So this management of the different VMs or management of everything else is being done for you by Cloud Foundry. And it's also making it easy for you to have the entire framework so that your application can run on it. And the reason you do this is because scaling these things, setting up the environment, and connecting to services are very hard, right? I mean, for a class, it's easy, but if you imagine that what you're doing in your class needs to be scaled to, say, the university, or has to go to a company because maybe you have a side company, and after you're done with your schoolwork, you start hitting some of the reason why these type of platform exists, because scaling those applications become hard, setting up the environment is hard, getting high availability or HA becomes super hard. And you don't want to reinvent the wheel, so you want to somehow have frameworks or a platform that does it for you. And that's why Cloud Foundry exists. And the cool thing is it's available today, so you guys can go and play with it and take your application and use it. I mean, at the end of the day, even if you're doing object-oriented stuff, except for Smalltalk, since we don't have Smalltalk framework supported, pretty much every other language that you guys could be doing right now, you could use a Cloud Foundry installation to run your applications, and of course on the web, right? So that's what Cloud Foundry is. The best part of it, I guess, before we move on here, is that it's all open source. So you can actually try it. If you decided to add Smalltalk support, for instance, you could do that. Or if you decided to change something in the existing set of components, you could do that, and you could contribute it back to the community. So this is the important part, I guess, to mention. And I'll talk about services later, because I think that's another aspect that's super important. So how is it kind of built? This is an old version of the way Cloud Foundry is built, but basically it's a collection of components. So it's a distributed systems in some way, and each component has a series of API to talk to each other. And you see in the middle here, there's this thing called NATs, which is essentially a broker for messages. So it's not unlike, like, say, object brokers, but what's flowing through the NATs is essentially representation of the object. So things like a JSON representation of the data between the collector and the router and so on. And it's using this pattern to communicate between all the different components. And so on the top here, I'll kind of describe each one of the components. You have UAA, which is sort of where authentication and authorization happen. So there's a database for that. This is all written in Java.
Mike,
yep.
Yeah. Is there a way to make the screen bigger? Do you know? Because we cannot see the graphic very well.
Oh, really? Okay.
I don't know.
Is that better?
No.
No? I guess you guys can go to the slide. Did you send the slide to everybody?
Yeah. Let me see if I can.
Yeah. So if you guys bring it up on your side and go to page 4, then it will make it.
Yeah, it's gonna be better. Let me look for it.
All right.
Okay, page 4.
Yeah, exactly. So if you go to that.
Yeah, that's better. Okay, let me know when you want me to change the slide.
Oh, okay. So you'll just use that to switch every time?
I guess so. It's better to. I don't know. What do you think?
Yeah, you can do that, and then I think at some point we can go back to my slides because I don't have complex graphics. Right?
Okay, great.
Okay, so we're in slide 4 right now. So on the upper left corner, you can see that UA, and I already described it. The one below it is a cloud controller, which is essentially sort of the brain of the whole operation in the sense that every request flows through this. So the idea behind Cloud Foundry is you have an app, and then you just go to the command line where the app is, and you say CF push. And CF is this CLI that you download. It's written in Golang. And when you do CF push, then that CLI will communicate with the cloud controller and take all your application, package it into some kind of a tarball, and send it to the cloud, and then ask the cloud to deploy that application. And Cloud Controller is sort of the traffic cop for this. It's all written in Ruby, by the way, this Cloud Controller. The component below it, syslog, is essentially keeping track of log of all the platform. On the right-hand side, you have a health manager, and kind of like a DEA, directory server, warden server, and warden container. Think of this as essentially taking a VM and slicing it into small sections so that you can run the application. So instead of running your application into one VM, a VM can be divided into small slices so you can run multiple versions of those applications. So you can see a lot of what the DEA does is essentially taking requests for staging an application, downloading the runtime of the application. So in the case of Ruby, you have to download the VM for Ruby. In the case of Java, you have to download the Java VM. You download all the necessary packages. Then you set up that environment for the language. And then you take the customer's application, and you're going to stage it so that it actually can run. And of course, the customer's application kind of a bunch of dependencies, and you have to go get those dependencies and set it up. So that's what Cloud Foundry does. It does all that. But it also makes it easy for you to say CF, once you have your application deployed, you can say CF scale, and then you say to 4, and it will create just 4 instances of that application. And of course, most of those applications are servers, so there's the notion of a port, so you can access it. So there needs to be some kind of a routing between the external customer to the actual container. And then plus, if you have multiple versions of the application, then you need to have load balancing across those. So it will automatically do all that for you. And the health manager, the component above, all written in Golang, is essentially monitoring all the different applications and seeing when they go down, because they often go down, meaning the container fails, the application fails, the VM fails, and then trying to recover from those failures. So if your application is running and one part of your application went down, then you can reconnect. Now, this is the basic Cloud Foundry. So IBM has an instance of this called Bluemix, and I encourage you guys to go and try it because you can get started for free and try it. And of course, if you like it, then you can just get your own Cloud Foundry and install it yourself, right? But at least you can get started on Bluemix, which is kind of a nice way to kind of get a feel for what's available. Now, in addition, okay, nice. So, you know, I'm not trying to make this advertising for Bluemix at all, but on Bluemix, if you switch to the slide, so I can show you guys very quickly. Yeah. This is gonna set up the next part.
Yeah.
Okay. So you see, this is me logging into Bluemix, and what's important is not so much the fact that it's Bluemix, but it's the fact that there is a catalog of services available. So in some ways, it's for things like if you go, of course, IBM is famous for Watson, and you can go to Watson and see a bunch of different types of services that are very hard to do yourself. So for instance, one is like personality insight. So if you click on that, then you can see what it does is that it derives insights from transactional and social media data to identify psychological trait, which determine purchase decisions, intent, and so on. So you can take your application, connect it to this service, and if you pull a lot of data from, say, social media, then this service can tell you, for instance, that this particular group of social media data has people in it which you can identify with their @ sign that are likely to buy your product, right? Or that they are talking badly about your product. And you can see the way we're charging for these things are like per API call, and you can see like it's 60 cents per API call. So anyways, the point is that with this platform, and the fact that we have Bluemix on it, and Pivotal has Pivotal CF, and HP is on board. Microsoft just announced that you can run Cloud Foundry on Azure. So there's a series of different big companies that are adopting Cloud Foundry. It's creating an ecosystem of those services so that when you build your application, you can extend your application to be even much more fun by adding some services on top. So this is the next set of I guess for this presentation is to kind of discuss how to extend the platform with services, right? So the problem is you want to be able to add different kind of services, meaning maybe you have potentially like services to back up data, right? Maybe you have a service like an object database. I mean, right now there's like a lot of NoSQL database, so basically document-oriented databases. There's also SQL, MySQL, and so on. So a series of external components that you need for your application. And the way we wanted to do this is to make it so that you can discover, integrate very easily to the platform. And this is kind of how it looks like. You could go to a UI like the Bluemix, or you can go to the command line and you download this CLI called CF, and you say Marketplace, and it shows you all the different services that are available. And right now we're showing you two, but you can have many. Then once you do this, you say create a service instance, and you can see here it's saying I'm creating a service instance called my DB on my service with some plan. So each service can have multiple plans. Maybe one plan is a free plan, another plan is a paid plan, and so on. And then you can say things like, bind your service to the app and then restage your app so that now the app will be restarted with access to the service. And we do this through the platform. Of course, we had various goals like to make it easy for developers to maintain their services. So in theory, you guys could, if you found something interesting to build, on top of Cloud Foundry, you should be able to create a service broker and have that service broker be integrated into different platforms. There is a open marketplace called AppDirect in addition to our marketplace that you can use. And it allows all the external vendors to kind of bring their service to CF, right? And you can cover them, integrate them dynamically. Guys, sorry, but I'm taking. Hey, no, not you guys.
Oh, okay.
Yeah, there's people around me. That's why. Maybe I'll move to a room.
No problem.
So the service model is the service broker architecture. And the idea is that you have kind of like this translation layer with a small HTTP interface to allow connection of the broker within the platform. So this is kind of how it works. Everything is essentially REST-based, so you have these REST API interface in between the different components. So what you do is you bring your broker and you connect it to your the cloud controller by saying create service broker, which essentially goes to the broker. You pass information where the broker is, of course, and it goes to the broker and asks for the catalog of the broker, and the broker will essentially send back a JSON, which is a description of all the different services, right? All right, let me move to a room because this is impossible.
Okay.
Just give me 1 second. Guys, it's impossible. I can't take the call. No, but it's not fair, right? I mean, this is a business place. All right. I don't know if they're going to kick me off this room, but it should be okay. Nobody shows up. All right. Can you hear me still? Hello?
Yes.
Oh, okay, perfect. Yeah. So this should be quiet. So once you add your service broker, then you can go CF Marketplace, then you will see your new service being added, right? So that's kind of the idea. Then when you use the service, you create an instance of the service. And what ends up happening is you get a request to the broker to create the service instance. And this means that, for instance, if you were to add a object database, what you're doing is you would be setting up the object database. Or if you were adding some kind of a fancy service, you would have to do all the work to get the service up and running. And then based on that, then the service would be, you'd have a pointer to where the user can actually use the service. So in the case of a database, most of the time you'd have just a URL for where the application can go and connect to that database, and then use, so like ODBC, right, or JDBC, depending on which kind of database it is, and then having credentials so that you can use those credentials to log in to that endpoint. So this is what I'm showing here when you actually have the credential information needed for connecting to that service. So what we've been doing this year, and I was part of the team to do this, is to essentially add support for long-running operation. And this, you know, and a lot of it is because in this time that you requested it, the service to be created and the time you can use the service, because of HTTP, you essentially have 60 seconds before, you know, the request returns or times out, right? So you have to return. So that meant you have to either get all your service ready in 60 seconds or return a service that's not quite ready to be used. So what we did is to try to solve some of those problems. So the first thing we did is to sort of do a synchronous operation, which is this common pattern. I'm sure Ernan showed you guys this kind of pattern, like future objects. So instead of returning immediately you know, all the information, you return an object that has information about what that last operation was and the state of it, so that you can pull, using that future object, the state of where things are, and then hopefully at some point it will be ready for people to use. So this is what it got converted to. So this nice picture you saw before gets converted to something more complicated, where the request comes in and you say you accept it versus you say created. So you can see the difference. Before it was 201, now it's 202. And then now you have a new thing called last operation that you can actually get, and it tells you the state of it, and then you can keep pulling that last operation until the state gets converted to succeeded or failed or something like this. So that's kind of the one of the changes we did. So you can see the change there, right? And the good thing is we actually did this pattern for all operations. So it's not just create service, it's also delete service. So when you delete a service instance, you can have that delete take a long time. And the important thing there is, like, say for instance the service was a database, your delete could guarantee that the database got backed up, right? Or that it got completely deleted from the hard drive, right? So things like this are the kind of additional properties that you can provide as part of your service to differentiate yourself in the marketplace. Another thing we added was service keys. The idea there is, so it's a new object called keys, service keys. Before, if you remember, when you created a service and you said you wanted to bind to the service, you had to get you got past the credentials. And the problem with this is you get one credential, one set of credentials for that service, but what you really want is to be able to have more of a open fashion for creating an object called service keys and then use that credential as part of the service keys. So we did that. There's some advantage for it because you can do things like, for instance, when you have an instance of the service, let's say it's a huge database with a lot of data, you might want to have multiple credentials because you want to distribute access to that service to multiple applications. Or even within your one application, you might have different parts of your application where you want to have different credentials, because maybe parts of your application is shown to the user and that credential is read-only, and then part of your application is administrative and your credential there is read-write. So it gives a flexible way for accessing services within CF and as well as outside of CF. Maybe you want to have a Docker container that talks to that service, right? So you can do all this to those credentials. And the idea there is essentially adding a new endpoint. So think of it as a service key object, and now you can post to create a new one, get one, and then delete it. And the beauty is that the broker doesn't have to change much. The broker just has to support that feature, but it doesn't have to change in terms of its API. This is an example of how you work it. You use it. So you say create service key, and you pass the name of the key that you want. So in this case, my key 1. but you have to have created a service before. So it's not, you can't do it without the service being created. So you see we're passing the service that we want to create the key on. And then now we get back an object which includes credentials. And that object could have more things. So these are JSON objects, so they tend to be, you know, flexible in the sense that you can add more information. You have to at least have credentials, but you can add more things to it. And then when you get back a key that you can now use. And then of course you can create more keys, you can delete them, you can sort of do the basic stuff with a key. The final thing is that that we added to make the whole service architecture better in Cloud Foundry is to support arbitrary parameters. And the idea there is that when you created a service, you couldn't tell it. So you almost have to think of it as a distributed system where you have these different objects, and when you're creating one, you're creating it from this external place that you don't know who's going to create those instances. And a lot of time you don't have enough information to be fully ready. So you want to be able to be flexible and provide configurable parameters so that when you create it, the service can be ready to use, but maybe you have configuration to allow the service to be more customized to the user. A good example of this is when you're creating a database, obviously, you know, in the way you did it before, you would set up your server and then you would run your database and then you would just go as an administrator and configure the database based on what you want. Like for instance, the size of it, the IOPS, and all the different configuration parameters that you would need for the database. But now that you're using the database as a service, you have to pass some of this information. You know, the default is usually not what people need, right, for any application. So this arbitrary parameters is to enable the ability for you to pass a JSON screen of key value pairs for these configuration parameters. But in addition to doing it in the create, you can also do it in the delete. Like for instance, you can say delete service and then pass a configuration arbitrary parameter that says completely wipe this database from the system immediately, right? Because maybe it has sensitive information, or maybe you want to back up that data and back it up, and it will tell you, you know, this is where I want it back up. So this is kind of what we did. So it's very simple kind of addition, but it opens a huge number of use cases. And so it's a new JSON parameter, and this is how it looks like. So when you say create service, you pass some plan, the DB, and then you pass a parameter that says maybe charting is true. And then you may want to pass like what's the database size, maybe it's a large database size, right? So if you guys go to this demo, then you can see a little bit of what we're doing there. So maybe we can look at the first demo, Ernan. I'm going to try to.
Yes.
Okay, so I'm running it right now. So this is an example of a, so let me set it up. So what we needed to do is to create a, so let's set it up. Are you still sharing my screen, right?
Yes, yes.
Okay, so let me show you guys this, because I think that might be interesting and it'll be a good thing for the next one. So if you guys go to, if you on your own computer, you can say go service broker. So I created well, you know, part of this work. We created a open service broker in Golang. So this is it right here, and it's actually a pretty simple service broker in the sense that it's designed to showcase those things that we just showed you, right? Like the new features. But it's a full-blown service broker in the sense that you could use that code to modify, or at least to be inspired and write your own service broker. But and the demo is going to show you what that does. But this is what Go code looks like. You know, this is like a main of it. All right, you can see it looks like functions, but it's not functions. This is an example of you know, calling an operation in Go, like check cloud name, and you get an error. And in Go, there's no exceptions, so you always get some kind of an error, and you have to check for it. The last thing I want to show you guys is like the concept of interfaces in Go. So if you go to client, I believe we have a client interface. So let's look at this.
Mike.
Yep.
Could you make the font a little bigger?
Yeah, we can do that.
Okay.
So this is an example of an interface in Go. So you say package client and you say type client interface. So one of the things about Go is everything is reversed. So you can see you put the name first and then you put the thing, what that thing is after. So in the case of like a method, you start with the name, you put the name of the parameter, and then you put the type, and then you put the type of that function, what it returns. In this case, it's returning two values, a string and an error. All right, and it looks weird and it feels weird at first, but it actually turns out to be very, very good. You can read about why this, Bob Pike, the guy that created a lot of Unix and Python and C, is the one that created this language, and they have various reasons why they did this, and it turns out to be much easier than the normal way of C or Java, where the type came first. And it's especially good for things like pointers to function and pointers to pointers and so on, things like that. And one more thing to show you about Go is that, so you can see here you're defining a type, right? So it's just like a Java type, or I guess I'm not sure what else does type anymore. But it's anything that implements this interface type, essentially behaves like this interface. So in this case, we define a client, and we have multiple implementation of this client for SoftLayer or AWS. AWS is, of course, the Amazon cloud, and SoftLayer is an IBM cloud. So I'll show you that one. And you can see here that we define a constructor which says new SoftLayer client, and you can see here it's returning a pointer to a SoftLayer client. That thing, SoftLayer client, is a struct. So you can do type struct, and then you have things inside that struct. Think of these as the instance variables. So you define them like this inside a struct, and then you define the functions. So in this case, this is a constructor, and you can see here it's essentially saying it's getting some default. Okay, I have a little typo here, but defining some default struct, and then it's creating an instance of that struct to return. So that becomes the object right there. One other thing about Go is that in Go, the lowercase is private, whereas uppercase is public. So in this case, this instance variable called VG_props, think of it as virtual GEPS properties. I mean, it doesn't matter, but it's just an instance variable which is defined here. And then you can see we have here the type of it, right? And that type is another struct, right? You can almost read the code, right? It's pretty straightforward. So you define a private struct called virtual guest props, virtual guest properties that has no host name, domains, .cpus, and so on. And then we have the instance variable VG_props of type SoftLayer client, and you can see here we're returning that type here. Now that type becomes the object because it implements each one of the methods. So you can see the way you implement the methods is that, or the interface that I showed you is that you have a function for that interface, right? And you return here, oh, sorry, no, you don't return, you pass the this. So this is the this C here is a pointer to the instance variable is the this. So somewhere in there I can use this guy like here. I could have named it this, but we just named it C for client.
Why not?
What's that?
Why not self instead of this?
Yeah, you can name it whatever you want.
No,
Go doesn't care. Yeah, you could name it self too. Yeah, definitely. But the point I'm making is that in Go, all you need is to implement each one of the functions in the interface. So if you remember, the interface has for create instance, get instance state, inject key pair, and then this is the signature. You just have to make sure you implement that. And if you implement that, and you have to pass the instant, the self, basically, or this, which is done here, that way, right? It can be a pointer or non-pointer type. If it's a pointer type, it means that the receiver can modify the instance variables. If it's non-pointer type, it means that whatever happens gets, essentially disappears. So it has the notion of whether or not, I guess, when you create an instance of that type, if that instance is, does it have a side effect or non-side effect? If it's a pointer, then if you call a method on that instance and you call a second method after that first method, then the change in the first method persists in the second time. If you don't do this, then you don't get the change. You always get a brand new instance, right? So that's one of the interesting kind of decisions that they make. And that's pretty much it. There's nothing else. Everything else looks pretty much the same, right? You have to be doing those if checks every time, which is a bit verbose, but it's actually very good in the sense that it forces you to deal with the error right there. So you can never, you could ignore it, but then you'll fail somewhere. But every time you make a call, you get an error. If you get an error in that call, you have to deal with it. And that's part of the beauty of Go in some ways. So there's a lot of reason why Go is great for cloud. I didn't show you any of those reasons right now. All I'm showing you is the basic syntax of it, because I'm showing you a broker that we're going to show you a demo of. So this broker implements the interface for I guess, the service broker interface of Cloud Foundry. And it does it here in the web server because it's essentially a web server. So I'll just show you the controller very quickly. So you can see here it has a catalog, right? Because remember we were making call for catalog. It has. I'm sorry.
Sorry. Yep. Could you make a little bit bigger the font?
Sure. So you can see here we have in this web server, which is implementing the broker, of course, a constructor. And then we have the catalog, which is essentially the catalog interface of that broker. And then we have things like create service instance and then delete service instance and so on. And all of what you're seeing here is web calls, right? Because you have to manage the fact that you're calling, you're going to be called on this with JSON payload, and then you have to unparse those JSON payload and parse them and and so on, right? And then, of course, you have a client to talk to the cloud because our broker is to spin up VMs. So we needed to demonstrate the new features that we talked to you about, like the async, the keys, and arbitrary parameters. And the way we did this is to create a broker that spins up VM. And it can spin up VM either on Amazon or on SoftLayer. And when you spin up the VMs, of course, the VM is a resource that you're serving, but that resource, as you know, takes a little bit more than 60 seconds to come up online. So that's the reason why we thought it was great, because we can showcase creating those VMs and then showing that it's not going to be immediate. So therefore, you have to pull to see when the VM is ready. The second feature is the service keys. Obviously, a VM when it's ready is useless if you don't have credentials to talk to it. So creating service keys will just return, like SSH keys. And then arbitrary parameters, to demonstrate this, on the case of AWS, when you're creating a VM, you can pass it the image ID. So let's show the demo of this, and then we can go back to the code as needed, right? So the demo is this is the first one. This one is to show the asynchronous parameters. You can see we went to AWS. We showed there's no instance. One quick thing here is you see on the right-hand side, we're starting the broker. And because it's Go, the broker is essentially hold on, let me stop this for a second. So what you saw before is, so here we ran the broker by doing out broker, and you can see it's starting on port 8001. The important thing is in Go, when you create something, you build something in Go, you build an executable, and that executable, you target a particular machine. So the executable has everything in it. So there's no other dependencies but the executable, and the executable is targeted for the Mac or targeted for Linux or targeted for Windows, and then you can just run it. So in this case, you can see we're running it on the right-hand side, and then on the left-hand side, what we're doing is to show to show what happens, when you're gonna try to talk to that broker, because you have to add the broker, right? So you use the CF executable, log in, you pass the API endpoint, you authenticate, and you can see here we're logging in. And then you have to say create service broker. Now, it assumes that the user ID that you logged in is an administrative user, because you can't just add broker to anybody. But you see here, we're adding a broker. We pass the user ID and password, and we're passing the pointer to where the broker exists, right? So in this case, it's HTTP request to 8001. And you can see what it's doing is it's talking to Cloud Foundry and creating a broker. And of course, you can say you have to enable the service instances, right? Because you could add a bunch of broker, but it doesn't mean that you have to have all services on all those brokers be enabled. So in this case, you can see we're enabling the AWS service. And then now if you say CF Marketplace, it will show that new broker, right? And you can see that broker has different plans, micro, small, and so on. And it allows you to create VMs. So what we're gonna do now is gonna create a VM, right? So that's the next step. So the next step, creating the VM, is creating a service instance, right? So let's see what happens here. So here, so we do CF, create service instance. And you pass the name of the service, you pass the plan, and you pass a name for the actual service instance that you want to create. So in this case, we're going to just create a VM. Okay, so it's delayed a bit, YouTube playback. All right, so now it's creating the service instance. And you can see it started the service instance, and the service instance is pending, because on Amazon it still takes more than 60 seconds. So it's gonna return that future object, and then we'll be able to pull to see when the service instance is ready. So we can use something like watch. You guys can go see those demos after, right? I'm just describing it to you, and then if you want to see it, you can just go see it after on YouTube. But you see here it's showing the status as being created in progress, and then it's going to keep, because the watch command will just call that same command multiple times. Eventually, soon, you'll see that it's created, and then we'll be done. And I'll show you one more thing, one more demo, and then we'll move on to the next. So you can see now it says created succeeded, and then the operation will end. So it means that now the service is ready for you to use, and if you go to the AWS console, then you can see that the service is running, right? So that's this first demo. The next demo is to show you the create service keys. So let's do that quickly. It's a short demo, but the idea is it's continuing on the same first one. So now that you have a service instance created, if you log in again, then you can see your service, right? So you say CF services, then you'll see that your service instance is there, right? VM1. And then you'll be able to now create a service key for that. And it's very fast, because it's essentially it's creating a SSH key and uploading it to that VM. And then it's returning you the service key, which it created it here, but you can say CF service key, and then you pass the name, then you can get the detail of that service key, in which case it's an SSH key. So now you have SSH key, public IP, and username, so that allows you now to essentially SSH into that VM. All right, and that's the next thing that we're gonna show you here. SSHing into the VM. So you can see that with this simple API of Service Broker, you can add any number of services, right? And all of this, as you saw, is a demo Service Broker that we created in Golang that you can use to create your own service brokers. And based on the interaction that you're seeing, when we go back to the code, you can get a better feel for where all of this is happening. All right, in this case, you can see we log into the VM, and then we basically have a basic VM. So that's that's the service key. The last one is, and we're going to skip it, but the last one is essentially parameters. And what you do is, instead of creating the service instance without passing any parameter, you can create it and pass a parameter to say, I want to use this AMI. And what's going to happen is it's going to spin up a VM using that AMI, assuming you have access to that AMI. So that's an example of how you pass parameters to configure the service instance that you have. So the other thing I want to mention is that how do you participate on something like this, CF? Because certainly, I'm sure you guys are building applications, and if you want to run them on the web, especially if they're web apps, then you can use CF, right? The other important thing is, because it's OSS, then you should be able to use the source and do whatever you want, right? We have a bunch of incubating projects. So one important project to mention is a project called Swagger. So let me just put that up. So CF Swagger is essentially a description of these APIs and Cloud Foundry in this language called Swagger. So I'll show you an example of it. An example of this is like the CF Service Broker itself, right? So this is the description of it. And I'm sure it's not very good because it's, you can't really see it here, but you can see it's JSON that says it's specify Swagger, what's, some metadata here, and then you can specify the path, and part of that, API, the Service Broker API we just looked at, is the catalog, and it's a get, and it has these operations, and then it produces this kind of data, and it has these responses. So in some ways, it's like WSDL, but better WSDL, right? It's a description language for APIs on the web. So you can take a look at that. It's definitely something that we are looking into right now. Part of it is we're looking at using this to generate code. So for instance, you can use this description to generate what we call a TCK, or like a test compatibility kit for APIs. So that's part of what's interesting here. We have other things, like for instance, we have a Bacchus and a bunch of different incubating projects. And of course, you can create your own service broker, right? Which is interesting. Finally, for CF, there's lots of documentation, right? There's things like docs, the services docs. If you are interested in looking at, how to use Cloud Foundry, and if you wanted to set up your own Cloud Foundry, there's Bosch. That's interesting for you to look at. So Bosch.io, it's worth it. And then there are different installation of Cloud Foundry that you can start using, like Bluemix, to deploy your applications. So with that, let me stop for a second. Of course, these things don't happen by one person. It's a full team. This is the team of pivotal employees that I've worked with over the past 6 months to make some of those new features available. So with that, let me stop for a second and see if you have any questions, because one thing I want to do is, see if you have questions, and then the next step is to discuss, why I think Go is such a great language for building such complex systems. Because you have to remember, a very simple installation of Cloud Foundry typically involves about 16 to 20 VMs. This is virtual machines, right? Yeah, because it's enterprise features, it has all these. And then if you look at something like Bluemix, it's in the 100 VMs. And this is Bluemix because it's supporting many users. So you have potentially, I think we last announced that we had close to 1 million registered users. With, if you imagine each one of those have at least one application, so you have at least 1 million application running, and then each one of those applications is talking to 1 or 2 services, then you can have 1 to 2 million services being connected to. And that's just the beginning of it, because Bluemix is only a year old. And one of the ways that we are essentially selling Bluemix is not necessarily just the public version, it's also the private version. So if you're a big customer, like a bank or any kind of enterprise customer, you may want to have an entire instance of Cloud Foundry just for you. Like for instance, at the university, you may want to play with Bluemix, but at some point, if you're interested in using it as a platform to test your application or to try your application, you might want to install Cloud Foundry yourself, in which case you'll have to set up a cloud like OpenStack, for instance, and then use that OpenStack, or use AWS or use SoftLayer. So you're paying those, or you get some free credit, and then you install Cloud Foundry on that cloud, right? But that Cloud Foundry is essentially a collection of 16 VMs, and each VM is running 4 or 5, 6 different jobs. So you can see the complexity of it, right? Mm-hmm. So why is Go important? Or what kind of language? We use Ruby to build this, right? The first version of it. And it was a terrible mistake. And Ernan knows how much I love Ruby.
Yeah, I know.
And it was a terrible, terrible mistake.
But why? Why was that?
Well, so let me try to see if I can find that other presentation, because I have another presentation that essentially tries to make the case for that. So let me just pull it up. Hold on a second.
While you're looking, I have a question about.
Yeah, go ahead.
Sure. So who is behind the IBM, the company, or? So
good question. So Cloud Foundry started at VMware. So the first version, maybe about 4 years ago, was at VMware, and then VMware made it public. And when they made it public, they essentially spin up a part of VMware to manage it, or to deal with, right?
Uh-huh.
And that spinned up version of Cloud, or that spin up company became Pivotal. So Pivotal, in some ways, is a spinned up. Well, it's complicated in the sense that Pivotal Cloud Foundry is the VMware group spinned up in a separate company, but that separate company also did other things, like, for instance, services, mostly Ruby and Java and iOS services. So they would work with clients to build stuff for them. But they made it open source, so they invited people to participate. And that at that time, it wasn't ready for production, but it was close. So we jumped in, and the team that I'm working for now, because I left IBM Research to work on that team full time, we are essentially helping Pivotal to make Cloud Foundry. So in some sense, Pivotal owned Cloud Foundry, and then it got transferred to a organization. So if you see my screen right now, then you can see cloudfoundry.org is a organization that owns it now. So it's a industry standard platform for cloud applications.
Okay.
Right. So it's open source and anybody can participate in it. Now Pivotal, because they initially started as the user of Cloud Foundry, as the owner of Cloud Foundry, has significantly more resources, but that's changing because, from 2 years ago, it used to be 100% Pivotal and or let's say 99% Pivotal and 1% from IBM and other places. Now it's more like 80-20. So there's 20% of contribution coming outside of Pivotal, and it's growing very, very fast, right? For instance, I'm the product manager for 4 or 5 projects right now, and we have more people. We already have close to 20 people, and as you know, IBM is a very big company, so we have quite a bit of invested and that's just us. So there's also HP, there's GE, there is Swiss Telecom, there is Fujitsu, there is HP. If I mention EMC is also part of it. So there's a significant number of organizations. If you go on the website, you can see some of the sponsors.
Okay.
Right. Okay. So after working at Pivotal for a while and never have program in Go, I realized the value of it. So I put together with Tim. Can you see my screen now?
Yes. Yes.
Why do Ruby developer learn programming Golang for the past 6 months?
No. We can see it's like a web page that's showing the Cloud Foundry. Now we can see an ugly face. Oh, it's you. Sorry.
So let me share another screen.
So what happened? You don't have light over there?
Yeah, well, so you remember I moved out of So I went to a room. So let's share something else. So I want to share this because I think this is maybe the part that you guys would be most interested. I didn't want to just go straight to this because I think the problem with this presentation is that it assumes you understand CF, you understand all this. So I want to go through what I think a Ruby developer, in some ways, maybe also the same as a Smalltalk developer to some extent, or a Python developer. What you can learn from Golang, right? And some of it is controversial. So, as I mentioned, Cloud Foundry is an open source platform. Cloud Foundry is the basis for Bluemix, for instance, and PCF, which is the pivotal Cloud Foundry. It's also mostly Ruby and shell scripts. That's what it was created on.
Mike, sorry. Okay, we cannot see the presentation.
You cannot see one. Okay.
Yeah, there is no presentation.
Oh. I was trying to share. Hold on. Share a screen. Right here. Do you see it now?
Yeah.
All right. So this is going to be quick, but it's going to hopefully create some controversial comments, and then I'll try to wrap it up in 20 minutes, and we'll have 10 minutes for questions because I have to go at 3:30.
Okay.
So what we learned. So first, we'll just repeat what we mentioned before, which is that,
Mike,
it's OS. Yeah.
Sorry, again, it's like when you do the presentation, we get a black screen.
Is it okay now?
Yeah, now it's okay, but it looks like when you do the present or something.
Oh, it switches to black? Okay, so I'll just do it like that then. Okay.
Okay.
So first thing is that, hold on, let me just zoom in then. Maybe that would be better. Maybe 125. And
Cool.
yeah, there we go. That's good, right?
Yes.
All right, so Cloud Foundry is open source. It's the basis for Bluemix, as I mentioned, and lots of different companies are investing in creating their platform out of Cloud Foundry. It was completely Ruby, right, and some shell scripts. And as I said, terrible idea, right? And I don't think it's just Ruby. I think Python would have been the same. Smalltalk would have been the same. Whatever language that you use would have been the same. Because they don't have some of the features that Golang has. So the components are gradually being rewritten in Golang. And I was part of pretty much all of the different teams, pairing with them. And this is what I learned in the past 6 months. Now, I created a presentation with Tim, one of my teammates, about 4 months ago. So some of it might change. So if I find them, I'll tell you. Okay. So number 10. Number 10, speed, right? Speed matters. And the reason is because a lot of these interpreted languages can be fast, and you can have JITs that make it, better, especially around object management, so that you can have really decent, performance. But languages like Ruby and Python, and to less extent Java, because it has the JIT, it has a better JIT, performance has never been the feature. So they're never more performing than the rest, except for very specialized situation. And what's good about Golang is that it's compiled language completely, and you get a binary. Now, the binary you get is not super fast because the compilers are not necessarily fully optimizing, and Google is working on a better compiler, other people are working on better Golang compiler. So in time, it will get better because the language is new. But the fact that it's compiled and the fact that you get a binary means that you have somewhat of a decent base for performance in terms of executing straight on the hardware. And you remember, because you're running on cloud stuff, you got layers of virtualization, which slows you down. Now, it doesn't slow you down significantly, but it's enough to make it better than certainly interpreted languages like Ruby and Python, at least in our experience. Okay? The next thing is dependencies. Dependencies hell, right? And that's a real thing. And the problem in dependency hell is that in languages like Ruby in Python and Java, and I think less so for Smalltalk, your dependencies are not dynamic, right? Like in Ruby, your dependency is this external component that you need to load, right, dynamically. And the problem with this is that it creates a situation, or in the cloud, when you deploy your application, you have to deploy the dependency. And that means that you could vendor the dependency, but a lot of time you have a dynamic dependency that you have to load. And it creates more and more issues, especially if you have one VM that has to run multiple applications, because that one dependency, let's say this library that was important for both applications, but maybe application A depends on library version A1, and application B depends on library version 2. So you have to load library version 2 for both. But the problem is library version 2 might have broken something in application 1. Mm-hmm. Right? So dependency is a big issue. And in Golang, not that it's a full solution, but you don't have those dynamic dependencies. So in Golang, all the dependencies are baked in. So you shift the dependency solution or resolution, from the deployer of the application, meaning that the person that's going to take the application and run it for their end users, to the developer, so that the developer has to worry about the dependency resolution, so that if they use that library version 2 and it breaks something, they have to fix it. Because in Golang, when you build your application and deploy the application, you deploy a binary that has all dependencies baked in. So it's the responsibility of the developer to resolve dependencies. Super important. This is not something that, became obvious. I think it became very important for the cloud, because remember, you're building an application to be deployed on a cloud platform that somebody else is managing for you. So number 8, concurrency, right? One of the beauty of Golang is concurrency is a first-class citizen. So in Golang, we have this notion of Go routine and channel. They're not necessarily new concept, but they're built in. So what that means is you don't have to use any kind of libraries for threading. The platform provides these. I don't show an example here, but trust me on this. You saw the example for the Go. So if we switch, well, you don't have to switch, but you remember when I showed you the line of code for the broker, and I showed you C called the method, right? We had the pointer object C that said C dot, and then it called a method, right? So that method is going to execute in sequence in that routine, right? But to make it into a concurrent execution in Go, you have this, I guess this new language feature called Go. So you type Go, G-O, right, on your code, and then you say, so if before you said C print line, hey Ernan, right? So that will be executed in sequence. And if you instead say Go C dot print line, hey Ernan, that executes in parallel. And you can have as many of those, and it will spin up the thread to execute each one. So it's a really nice kind of like syntactic sugar for doing threading. But more importantly, you can also use channel to communicate between those Go routines, because now that you executed it in a different thread, what happens to synchronize things, right? So the return value of that function can be synchronized with channels. I'm not showing you an example here. This is one of the things I want to fix in those slides, but just believe me that it provides a very nice built-in concurrency in the language itself. All right, so the last one is that, number 7, I guess, the compiler is a friend to you, right? Before, people, especially with those dynamic languages, you have a compiler, but the compiler is not super important because you don't have static types, you don't have every part of the language being compiled before you actually move on to the next step. You don't have a linking stage. You don't have these dependency, everything is sort of dynamic. So the compiler is just checking for basic, syntax errors. But here you can have a fast compiler that's looking for very basic common mistakes. Of course, if you do TDD and you're a really good programmer, the compiler is just here, it's good for you, but it's not necessarily as important to you as before. But in languages like Ruby or Python, and I guess to some extent Smalltalk too, a lot of things that we saw in the cloud is that you build your stuff and then you put it on the cloud, and the errors happen at runtime later, because a lot of those errors that we saw was basic type checking stuff. So having a strong typing and using a compiler is certainly very important, especially because compiler technology is so good these days. That's one of the things, right? And so things in languages tend to go like this, where you get a wave of static typing, dynamic typing, static typing, dynamic typing, static typing, dynamic typing, and a lot of it depends on the state of compiler technology, depends on the state of garbage collection technology and so on. And I think at this point, because of the cloud and because of the state of compiler technology and various other reasons, I think having a compiled language actually is quite advantageous for you. Number 6, don't kill the mockingbird, or kill it, right? So one of the things that we've seen with Ruby and in especially Ruby is the abuse of mocks. So we would do TDD, and of course in TDD, as you have to kind of like drive your development with your tests. And of course, because you're doing this, then it means that you're doing a lot of unit testing. And because you're doing unit testing, you want to sort of isolate the part of the code that you're going to test. And a lot of time it means that the rest of the code needs to be mocked. Because like, let's say you're talking to a database. Well, if you're not testing the database and you're testing just code around the database, you want a database that is guaranteed to always return the same value on a query. So you mock the database. So you create a mock, and then when you talk to that mock database, it always returns the same values on the query, which is great. But the problem that we saw for large systems is that people would mock everything. And at the end of the day, you get so many mocks that you don't even know what you're testing.
Yeah, but the problem is
yeah, you could argue that this is not necessarily a language problem. It's a people problem, like a lot of problems. But I think having an environment or a language that helps prevent some of those common people problems is actually a good thing. So in some ways, in Go, we use fake objects, which is similar to mocks, but it makes it a little bit more difficult. Because I think in Ruby, part of the reason mocks are so powerful is because you have these dynamic mocks, right? So you create an object that can be anything in Ruby. So now that this object exists, you can just set it up to behave like a database. And that same object, you can later on in the code change it to make it behave like this other thing. And of course, that's bad programming practice. But the point is, because mocks are so easy to create in dynamic languages, you tend to abuse them. So that's the problem I'm mentioning here. Again, as I said, a lot of these are meant to be controversial on purpose.
Yeah, okay.
Next one, number 5, is TDD in type language is actually pretty fun, right? You think TDD and languages like Smalltalk is very, very great. It's powerful. I mean, I know I didn't know TDD until I saw, Ernan show me how he did Smalltalk programming using TDD, which is very powerful. But, in type languages like Golang, you can actually still achieve a lot of these fun, TDD development. It makes it, especially because the compiler can reveal the object interfaces for you. Mocks a little bit harder, but they're still, doable. I think you get some disadvantages, but it's not that much compared to the end result. So I'm basically saying that even with a compiler, even with a compiled strongly typed language, you can still do TDD, and it's actually quite fun. Another one is Vive les interfaces, which is basically that interfaces, which is a notion Java had and other languages have, is super, super useful. Having interfaces allow you to clearly separate the boundary of code. and this is a real problem that you get, you know, in languages like Ruby that tends to not necessarily have clearly defined interfaces, and even Python as well, right? You don't have those things in those languages, and it's a problem, right? Another one is the concept of a single finite binary, and it's super, super important. This is back to C, right? When you use C, you kind of compiled everything into a binary, and you know, people kind of went away from this, where you in languages like Ruby, you'd have the source files, and then you'd have all the, you know, I guess the libraries, and then you would run it into the virtual machine. With Go, you completely compile everything into a single executable. So it makes the distribution of this application or service or whatever into the cloud super easy. All you have to do is ship me a binary. Now, in languages like Smalltalk, you could also ship the image file, which is great, but you know, it's still pretty big because you're shipping the entire environment. Remember, we're running the Go executable within a container, which is within a virtual machine, which is within a piece of hardware in the cloud. So, you know, things, you get layers and layers and layers. And with, you know, an approach like Smalltalk, you'd have an image within that, right? So you just add another layer of complexity. So it's possible, but, you know, not as easy. One more thing is this check for errors. So in Go, this is an example of what I was telling you about, right? Every function call has an error return, which you can use to check, right? It makes the code a bit verbose, but the advantage here is that whenever there's an error, you deal for it right there. You don't wait, right? In previous languages, you just throw the error, and then somebody upstairs will deal with the error. And the problem with that approach is that, you know, you tend to miss them. You miss the context of that exception, right? In Go, you cannot. The code is right there. You could ignore the error, but the point is you have to deal with it right there. You either deal with it or you ignore. And you can have, there are linters in Go that will, you know, you can run them before you compile, that will tell you that you forgot to check for that error. So this is definitely a big advantage as well, right? And then the last thing is you have one style to rule all of them. So in Go, there is no style. There is this notion of format, Go format, and every code that you write will look exactly like every other Go code, because the Go format is part of the language. It will rewrite your code. So it means that if we write code, you know, you put your curly braces to the left or to the right, and you put it in the new line, Go will just rewrite it into one form. So there's a uniform style. And I think that's a very interesting thing, because it makes, I mean, of course you could in your own team say everybody should follow this style, but as you know, people will always deviate, especially new people, takes them time to learn and so on. Whereas in Go, the style is part of the language, which is kind of weird at first, but it gets pretty easy, because then you forget about style. You never worry about that, right? Everybody follows the same style because the language will force you to do it. If you don't write it in that style, it won't actually compile.
Oh.
Right? So that's really cool. The other thing that it does, which is an interesting consequence, which I didn't know before, or I discovered in some ways, is that it makes not necessarily meta-programming, but modifying code easy. You can write tools to modify code. And the reason you can do this is because, you know, one of the big problems with modifying code is if you're modifying code, you lose the style. So if you give somebody, you know, a little utility that will go through your code and add all those checks for errors, right, automatically, let's say, then you'll have to decide on a style. But because Go has one style, you can add that, and people that look at the resulting modified code cannot differentiate between that and code they would, because everybody has one style. So this is a really nice sort of consequence. And then the final thing is that it's, I feel that, you know, even though I love Ruby and Python, I think right now I'm just not programming in those anymore. I'm basically programming in Go as much as I can. And Go is open source, by the way. So it's not that Go is, you know, it's not controlled by I mean, controlled by Google to the extent that most of the key committers work for Google. But, you know, in theory, anybody, if you contributed enough, could become a committer and could take over any portion of the project because it's completely open source. So of course, you know, I'm not trying to tell you to stop programming in Smalltalk or Python or Ruby or Java, but I'm encouraging you to go and program in Go, and especially look at, if you're especially doing things like cloud computing, to definitely spend some time looking at Go, because those other languages have significant problem on those platforms. And of course, you know, if you're a language buff, if you're fixing languages or you're into creating your own languages, maybe it's a time to fix some of those languages, to look at Ruby and maybe create a better version of Ruby, or to take Smalltalk and hopefully create a better version for the cloud, because the cloud is the future. And having a language that would be better than Go for the cloud would be a really cool next challenge. So I would highly encourage you to write some Go code and maybe even deploy that Go code into Cloud Foundry so you can get a feel for that entire platform that I mentioned. So with that, let me stop and take some questions, and then I've got to go. So I have 3:23, so maybe we can spend some 7 minutes of question. I'm going to turn on the lights.
Yeah, great. Yeah, great. So okay. I didn't know that. So I have some questions, Mike. People is laughing over here because I always say the same. I have some questions.
Of course you do.
So Go doesn't have exceptions.
Nope.
Go doesn't have closures.
No, it does. Absolutely.
It does?
Yeah, because you can pass functions. You can pass.
But
you can pass functions. Yeah. And I'm pretty sure they are. I forgot how they call them, but it's essentially everything is a set of functions, and you can pass these into. And when you pass them, it will capture the variables around that function call. So definitely you can use closures.
Oh, because the last time I saw Go, like a year ago, I remember I didn't see it. Maybe there is a new.
Oh yeah, it's been evolving. Now it's already at version 1.6. Yeah, it doesn't have templates.
Yeah.
Yeah, there's no templates. I mean, if you like templates or not, it could be an issue. Great. Okay, good.
So okay, but you didn't convince me to use Go.
Well, so the key way to convince you
I understand
is to start doing clouds.
And the need to control the environment, the execution, you know, of the program that you are building. But at the same time, I see that it's like a better C, you know, or a better C++.
It is a better C. Yeah, it is a better C, definitely. But the point I'm making is, if you build application to deploy on a cloud, then you have to be very careful, because the new reality that you didn't have before is that you no longer control the executing environment. You now have an executing environment that is controlled by another group that is executing somewhere else. And what you want to minimize is the pain of taking your application from building it and testing it on your own local environment to this environment that now is in the cloud. In a language like Go, minimizes the pain.
Yeah, I understand. So you are trading deployment environment issues with programming development issues. So because the deployment issues are more important now, you're okay with losing some development advantages because you want better deployment, stuff. But yeah, from that point of view, okay, it makes sense.
That's exactly the point. And this is why I challenge people that still want to do things like Smalltalk or Python or Ruby to figure out a way to not lose those deployment, to fix those deployment issues and keep your programming, right? But that's a challenge, right? Nobody has solved that yet.
That's right, but because from the programming point of view, let's say we don't want to do an application that's going to run in the cloud. Let's say we want to do an application that's going to run on your workstation. So what's the advantage of using Go instead of Ruby or Smalltalk?
You have less advantages, but my point is every application now is moving to the cloud. 99% of in the cloud.
That's what you want.
No, it's not what I want. It's the reality. The premise that you had is no longer being true anymore. Everybody's on the cloud.
Okay.
Of course, I could be wrong about that, but I have like a 1% chance of being wrong, and you have a 99% chance of being wrong.
I agree with that. Okay, so I don't know. Does anybody want to make a question about Go, Cloud Foundry?
Did anybody try Go before? Anybody programming? No,
not here. No, it's not a common language around here.
So let me suggest this to everybody, please. If you take one thing from this talk today, is this. You go home and the next week, download the Go compiler, right? Very easy, like small. And then go through creating a very simple application for Go. I don't know, like maybe like do a hello world first, and then try to do something simple, like maybe do a little data structure, or I don't know, and pick and choose whatever you want, and see how it feels. It's actually very easy and very straightforward. And the point is that if you like it after you try it, next time you have to do anything for the cloud, do a little programming and Go, because it is a bit different. It's a bit like, it feels left to right versus right to left kind of deal. But it actually, after a while, very, very, very powerful. I mean, I cannot tell you how many people I've told to try to do this and became Go converters, or at least, for things that they're doing on the cloud. So.
Okay. And what about debugging? I mean, does it come with good tools to debug and?
Okay, so this is where it's a bit a pain. Yeah.
Okay.
It doesn't have as many tools, so that's a problem. There is one.
And memory management, I think it's manual.
Yeah, it has big memory management. There is one thing you can do with it. So, and for instance, hold on.
Sorry, I didn't understand. Does it have automatic memory management or is it manual memory management?
It does it for you automatically.
Oh, okay. But why do you have to pass pointer?
No, you can still have pointers because it unlike Java, it has the notion of not everything is a pointer in Go. So it means that you can differentiate between things that are pointers to things that are essentially allocated on the stack versus the heap.
Okay.
And allocated on the stack, then you get new values. So if you created something that's not a pointer, the values exist on the stack, and if you get out of the execution context, then you lose everything. Whereas if it's a pointer, as long as you keep a reference to that pointer, then you can keep using it.
Okay.
So on Java, everything is a pointer. You don't see it as a pointer, but that's really what it is. Everything is allocated on the heap, whereas in Go, you can have both.
Okay.
So that's why you have to differentiate between which one you want. Do you want a value type or do you want a pointer type?
And how does Go goes with functional programming?
Actually, extremely nicely, because essentially everything is a function in Go.
Well, but that's not enough to say that you're doing functional programming. I mean, you have immutable stuff, and then you high order functions and those kind of things.
So you have built-in support for basic functional programming and basic object-oriented programming, right? That's the key. And it has concurrency support built in. And you have all these dependency management and all this stuff built in.
And why Go and not Erlang, for example? What's the difference? Because Erlang is...
I don't know, I haven't tried it, but I think part of the problem is that people found Go to be easier to use than Erlang. Erlang, the language is not as common, you know, it's difficult to follow or difficult to grasp. What we found with Go is that even though it's sort of like Python, the first time you use it, you have to remember like spaces, you know, and stuff like that. With Go, the first time you use it, you have to remember this whole notion of types. When you define anything, the type comes first, the types come after versus the type coming first. But besides that, it's very easy to get. So people that program in C, people that program in Java, they can easily get it. So that's maybe the advantage.
Okay.
So here's the other thing. Can you see my screen here?
Yes. Well, we see you, not your screen.
Okay. So let me change something because I want to show you one more thing to try very quickly and Go. So in Go, you can do this thing called a playground, which allows you to try things. So this is online, and you can run it. So you can see hello, say hello. I guess Argentina.
Yeah, Argentina, not Brazil.
Oh, I should say hola, huh?
Yeah.
And I'd have to do that little question mark on both sides, but I can't do it here with my.
Yeah.
So you can see with the playground, you can try Go code very easily, and that's kind of a nice little feature that exists.
Okay. Okay.
Okay,
we'll give it a try just for you.
Well, you know, I think, you know, I'm trying to challenge you guys, right? I mean, it's easy to stay in what you're used to. It's easy to keep doing the same things, right?
Yeah.
I mean, and I'm challenging you guys to look at Go, because I firmly believe in the next 4 or 5 years, the demand for people that know how to program Go is gonna go to the roof, and there's not gonna be enough supply, and that gives you a big market. And plus, you know, it's an opportunity. Like, you know, when people think of Argentina and Buenos Aires, I mean, I know from various places, people think of huge number of, you know, great computer scientists, but they also associate you guys with small talk a lot.
That's great.
And I don't think that's wrong. I'm not saying this is wrong. It's great, but maybe you wanna, yeah, I see. But maybe you wanna diversify.
Okay.
Diversify into something like Golang, right? At least take a look at it. Take a look at it. It's worth it.
Yeah. Okay. Yeah, it makes sense. Questions about the language? Yes.
Hello, Mike.
Hey.
Do you know what the creators of Go had in mind when they created Go? They wanted Go to be the language for cloud computing, or that's something you are claiming now? And what was the original idea?
Yeah, that's a good point. I mean, did they have cloud computing in mind? I don't think so per se. I think they wanted it to be a good systems language. So when you're creating systems, complex distributed systems, there's a series of common problems that you have, such as those dependency management, concurrency, and so on. And they wanted Go to be a very good systems language, a replacement for C, right? Because if you think of when you're creating systems, things that are looking deep into the hardware or distributed system and so on, you want to have a language that is very fast, that is close to the hardware, that, you know, allows you a series of advantages that you don't get with dynamic languages that are running on top of a VM, that have dynamic dependencies and so on, right? So they wanted a language that was closer to the hardware, and that's what Go does. And it turns out that it was perfect for the time because these cloud computing systems, you know, they are better suited for if you're building the cloud computing. Now, if you're building an application on top, right, an end user application, you can still do it in Ruby and it's probably faster. But if you're building a system, right, you're building the platform itself, like Cloud Foundry, it's better. So I'm not trying to say Go is better for building web apps. If you want to build web apps, use Python and Ruby and so on. But if you're building a system to run web apps, if you're building a system for big data, if you're running a system for operating system, a distributed operating system, if you're running that class of applications on the cloud, then Go is better suited. So let's be clear about this point, okay?
Yeah. Yes. And what do you think that Go is better than C? Is it faster?
I don't think it's better than C. It's just that C is hard. C, you have to do your own memory management. You have to, you know, the syntax is very complex compared to Go. The tooling is harder. It doesn't have a lot of the nice features that Go has. So in some ways, it's a better C than C. So that's the best way to look at it. It's a better C than C. If you still want speed, the speed that you get with C, then it's better to do C. But then you're trading off memory management, for instance, right? I mean, you're risking a lot of core dump in C that you won't get in Go. I mean, you still get core dump in Go, but you know, because Go is a little bit better at dealing with garbage collection, then you have less of these issues.
Okay.
And it's evolving. This is the other thing. It's evolving and it's open source. So if you're into language, you know, design, then it's an interesting language to look at because there's a lot of evolution around it right now.
Okay, cool. Well, the idea of this talk was to see a new language, to understand
a new platform.
A new platform to build systems.
That's right. In the cloud, because that's where the future is.
Okay.
It's all cloudy, man. It's all cloudy.
Okay, so I think it was great to have your point of view on that, and because you have all this experience, it's great to to see something like that. Like I said, I have to try it. I really didn't buy that Go is great, but some things never change,
That's right. Something never change. You have to experience it to know. I will send you the slides for the Go part because I don't think I sent it. Okay.
Yeah, please.
All right,
so I can send it. So, Mike, thank you very much. Your phone has ring many times already, so we don't want to take it. You have to do stuff for sure. So thank you very much for taking the time to talk with us, and we hope we do it again.
You're welcome. Anytime. Take care, guys.
Bye. Bye. Bye.
Bye.